So we'll pick up with example 16. This is on the bottom of page 28. 5 assembly machines can complete the job in 3 hours. So we have assembly machines and hours. And how many hours will it take 2 assembly machines to do the same job? So we have machines and we have hours. Again, 2 different units, so they're going to go on top of our box. And we have 1 situation and 2 situations. So the first thing we know is if we have 5 machines that can do the job in 3 hours. Then we want to know how many hours it will take for 2 assembly machines to do that same job. Let's think about this for a second. If the number of machines are going down, so we have fewer working machines, should it take more time or less time to get the job done? Well, it should take more time because we don't have as many things working. So notice that these arrows are going different directions, which means it's an indirect or inverse proportion. So we'll take the 5/2 directly, but this part, because it's an inverse, we have to switch. So we have x/3. So 5 times 3 is 15. 2 times x is 2x. Divide both sides by 2. We get 7.5 or 7.5 hours. Or half an hour, we know, is 30 minutes. The gear speed is inversely proportional to the number of teeth. Okay? And this is always true. So the number of teeth, if it has more teeth, it means it's a bigger gear, and that means it's going to go slower. If it has fewer teeth, lower number of teeth, it's smaller gear, it will go faster. So there's always this inverse relationship with it. Okay, so that's important to remember when you're talking about gears. So here we're talking about teeth, and then here we have speed. So we're going to use teeth and speed as our boxes on top, our labels on top of our box. We have gear A and gear B. So gear A has 16 teeth. Gear B has 8 teeth. Gear A turns at 40 RPMs. And we don't know what the speed of gear B is. This is an inverse proportion. It tells us it's an inverse proportion. This is smaller teeth, so it should go faster. So we're going to have 16/8. And this one will get flipped. We'll have x/40. So we'll do 16 times 40. And we get 640. 8 times x is 8x. We'll divide both sides by 8, and we get 80. 80 is underneath the speed, which is measured in RPMs. So it's 80 RPMs. It's half the size, so it goes twice the speed. Here's another gear problem. You can see we have 2 teeth and RPMs. Okay, a 12-tooth gear is mounted on a motor shaft that drives a larger gear. The motor shaft rotates at 1450. Okay, so we have a 12-tooth gear and it rotates at 1450 RPMs. The speed of the larger gear has to be 425 RPMs. So how many teeth should we have on that larger gear? And this was the motor shaft. So it's a teeth gear situation, which means it's an inverse proportion. So we'll write 12/x equals 425/1450. So 12 times 1450 equals 17,400. 425 times x is 425x. Divide both sides by 425. And we get 40.9411, and it keeps going. But we're talking about teeth on a gear, and we can't have a decimal number of teeth, so we need to round this to the nearest whole number. So we'll call it 41 teeth. And one more example. The pinion gear on the drive shaft has 9 teeth. The ring gear has 40 teeth. That's on the axle. What is the rear axle speed if the drive shaft has 1200 RPMs? So again, we have teeth and RPMs. We have a drive shaft, and we have the rear axle. So the drive shaft has 9 teeth, and it turns at 1200 RPMs. The rear axle, or the ring gear, has 40 teeth, and we don't know how fast it turns. It's a gear teeth speed thing, so it's an inverse proportion. So write 9 over 40 and x over 1200. So do 9 times 1200 equals 10,800. X times 40 is 40x. We'll divide both sides by 40. We get 270 equals x. This is underneath the RPMs, so our label is RPMs. It's a much bigger gear, so it's turning much more slowly.